4 years ago.
Today we're looking at graphing exponential functions that have a base of e, and we're also looking at solving compound interest problems. We should be able to knock this out in just 2 examples. So, graphing exponential functions with a base of e is the first thing we're going to look at. So let's say I want to graph y equals negative e to the, let's say, x plus 2 and plus 3. Let's say I want to graph it. So notice that my base is e. Anybody know what e is? It is a constant. So e is a constant. What type of constant do you think it is? I don't know. What do I need?
Well, I know it's like pi, but I don't know.
What is pi? What type of constant is pi? Irrational.
Oh,
Good.
that's nice. I don't know what you're looking
Okay, it is irrational and it is similar to pi. Okay, e is equal to like 2.718 and it continues on. Okay, so what do you know about the decimal that it forms? It does 2 things. What 2 things does the decimal do since it's irrational?
Never repeats.
It doesn't repeat
Never ends.
and never ends. So it doesn't repeat and doesn't terminate. So that's what I know about e. And again, it's 2.718 and it keeps going on. Okay, the reason why it's e is it's named after a mathematician that worked on it. His name was Euler. Obviously, you've got an e there. So the e, that's where the e comes from, is that he was one of the mathematicians. There's about 3 mathematicians, I think, that worked on this number. Okay, and this isn't going to make much sense to you, but e is equal to the limit as n approaches infinity of 1 plus 1 over n to the nth power. That's not going to make much sense to you, but that's what e is. Okay? But we'll do something a little bit later on the day that is similar to that right there, and it should make a sense why there's a connection between e and what we're doing today. Okay? So let's get back to graphing this. You're going to graph it in the same way that we always do. So what do I want to do to get started? Find my movements. So what movements do I have here? I got left 2. I've got over the x and up 3. So what does that mean my horizontal, Blake? What does that mean my horizontal asymptote is?
Your horizontal asymptote will be minus 2.
Y equals
Is it negative 2? Wait,
3.
I was looking at the 2 for some reason. That's my fault.
You understand why it's a 3 though?
Yes, I see it now. Sounds really good.
So since I had a vertical, whatever my vertical shift is, that's what it's going to be. Alright, so then we're ready for our t-chart. So I have x and y, and Christian, what is it I want to identify with my t-chart?
Would it be your 0?
It would be whatever makes my exponent 0. So what makes my exponent 0 here?
Would it be negative 2?
Negative 2. So then I pick 2 numbers bigger than negative 2 and 2 numbers smaller than negative 2. And then I'm going to need my calculator to work these out. So let's plug negative 4 in. If I plug negative 4 in, that makes my exponent negative 2. So I need to plug in negative e to the negative 2 plus 3 in my calculator. So negative e to the negative 2 and then plus 3. That gives me 2.865. Okay, then we do the same thing with negative 3. If I plug in negative 3, that makes my exponent negative 1. So I need to stick that in. So negative e to the negative 1 and then plus 3. That gives me 2.632. Then when I plug in negative 2, what does that make my exponent? 0. And e to the 0 power is 1, so I've got a negative 1 plus 3, which means that is 2. I stick in negative 1, which makes my exponent 1, so I have negative e to the 1 plus 3. So negative e to the 1 plus 3. That gives me 0.282. And then I stick 0 in there, which makes my exponent 2. So I have negative e squared plus 3. So negative e squared plus 3. And that gives me negative 4.389. So horizontal asymptote is y equals 3. So I put that in there. I've got negative 4 and 2.8, 2.9, negative 4, and so that's going to be way up there. Negative 3 and 2.6, so that's going to be about right there. Negative 2, 2, negative 2, 2. I've got negative 1 and 0.282, so somewhere around there. And then I've got 0 and negative 4.3 something. So about right there. So we should be able to tell that it's going down on the right and it's flattening out on the left. And again, like we said earlier, we want to make sure my shifts worked. Does it look like I went to the left? Did I flip over the X? And did I go up 3? Yes. So all my shifts work, so that means more than likely I graphed it correctly. So graphing exponential functions with the base of e is the same thing we did last week, except I have to use my calculator to plug in e. And remember, what is e?
A constant.
An irrational constant. Whenever somebody asks you what e is, the best answer is it's an irrational constant. So that's what I want to hear. All right, so now let's look at doing a compound interest problem. All right, anybody know anything about a compound interest problem? Say it again. There are two formulas we're going to use when we're dealing with compound interest. The first one is A equals P times 1 plus R over N to the NT, and the other one is A equals P E to the RT.
Just one.
Those are our two compound interest formulas. Say it again. On the second one, the first one is NT on the exponent. The second one is RT on the exponent. All right, so let's talk about what some of my letters mean in here. Anybody know what, or have a guess on what A stands for?
This has to do with interest.
Has to do with interest, so what do you think A might stand for? Close. A stands for account balance. Is what A stands for.
I thought it was a count, but that's true.
Anybody know what P stands for?
Principal.
Principal. What are we talking about with principal, Kathleen?
The amount you started with.
The
Like
amount of
if I
money
go
I
to the
started
bank.
with. Good, very nice. Okay, then we have R. What do you think R is?
Right.
R is my rate. Then I have N. I'll be very, very surprised if anybody knows what N is.
Number of months.
Close.
Number.
It is the number
Hey, I'm close.
of times compounded.
I got one word in
So the number of times compounded. And then what do you think T is?
Time.
Time in years. So T is our time in years. Same thing over there on the right. A is still account balance. P is still principal. Again, what is E?
Irrational.
An irrational constant. And then I have R is my rate and T is my time. So these work for both of them. Okay, now we use this one right here when we are compounding continuously. We use that formula when we're compounding continuously, and what do you think we use this one for? Not continuously when we are compounding a specific number of times. So when they give us a specific number of times to compound, we're going to use the first formula. If they want me to compound it continuously, we're going to use the second formula.
Specific? What'd you say? You said specific number?
When they give me a specific number of times we want to compound,
Okay.
I use the first formula. When we want to do it continuously, I use the second formula.
So whenever there's an end.
Whenever there's an n, you got to use the first formula. When there's not an n, you got to use the second. Okay, and this right here, when I was talking about n earlier, you should notice that that right there is very similar to what I showed you earlier on the limit as n approaches infinity, and then that right there is very close. You can do some manipulation to that to where it turns into what we were taking the limit up earlier, but I'm not going to waste your time on that. That's over your head right now. When we get to calculus, it'll make a little bit more sense. All right, so now let's use these on a problem, and then we'll put you to work. All right, so let's say I'm investing $5,000 at a rate of 3% for a time of 5 years. And I want to know how much money I make when I'm compounding 1 time, 4 times, 12 times, 365 times, and continuously. Okay, so I want to see how much, if I change the number of times I'm compounding, I want to see if that changed the amount of money I'm making. Now, what do we mean by compounding? Anybody have any thoughts on what we mean by compounding? Pardon?
How much of the $5,000 you were actually putting in the bank at the rate of 3%?
Not really. Any other thoughts? Educated guesses on what we mean by compounding?
What'd you say?
What did you say?
I said the amount of money that you are putting in the bank at the rate.
Kind of like,
Did you say she's not?
You're closer. Compounding is how many times a year am I actually figuring out how much interest I'm making and adding that to my principal. Okay? So if I'm compounding 1 time a year, that means I'm figuring 1 time a year I'm going to figure out how much interest I make, I'm going to add that interest to my principal to get a new account balance. Okay? If I'm doing it 4 times a year, then I'm going to figure out interest 4 times throughout the year and add that amount to my account balance. And 12, I'm going to do 12 times 365, and then I'm going to do it continuously. So what do you think is going to happen when I increase the number of times I'm compounding?
Isn't it students?
Let's find out. Let's find out. So on these first four, what do I need to do? I need to use the first equation, right? So I'm going to have my account equals 5,000, 1 plus my rate over n, and then I have n times t. Now, what do I need to do with my rate before I plug it in? I need to change it to a decimal. So what needs to be plugged in there? Okay, I need 0.03 plugged in there. All right, so then we want to go to our calculator, and I'm going to show you how to use your calculator to make this work pretty easy, pretty quick. All right, so we've got 5,000. I've got 5,000. And then I've got parentheses, I have 1 plus, then I need to put in a fraction. What do we do to make it easier to put in a fraction? Control divide, good. So I want to do control divide. Okay, and my rate was 0.03. And in this case, what is it over? It's over 1. And then my exponent, I need to get outside and then put my exponent in there, and my exponent was 1 times 5. And yes, everybody knows that 1 times 5 is 5, but there's a reason why I put it as 1 times 5, and you'll see whenever we do the second part of this. Okay, and then I press enter, and I now have my new account balance, which is 5,796.37. So 579637. So 5796.37. So what does that tell me? What does that number tell me?
How much you
If you
So how much money did I make?
796.
I made $796.37 because I started out with what? I started out with 5,000. So that's what I get if I compound 1 time a year. So now let's see what happens if I change it to compounding 4 times a year. So what would I do if I'm doing 4 times? Substitute the 4 for the n. So that means I'm going to substitute it at these 2 spots. So let me show you how to do that with your calculator. It's pretty easy. So what you want to do is you want to arrow up twice until this piece is highlighted. Once it's highlighted, you press enter and it brings it down for you. Then all I've got to do is go in and erase the 1s and put what's in its place. 4. So I go in, I erase the 1 and put a 4 in. I erase the 1 and put a 4 in, and I press enter.
Is that why I put the 5 in parentheses originally?
Say it again.
Is that why I put the 5 in parentheses originally? So it wasn't.
I don't think I. You took the 5 of the exponent?
Yeah.
No, I didn't put it in parentheses. I just did 1 times 5. But that's why I did it. That's why I did that instead of putting just 5 up there, because I wanted to replace the 1 with the 4. So I got 5805.92. 5805.92. So what'd you notice about how much money we made? We made more money. So let's see what happens when I compound 12 times. So again, what do I want to do back on my calculator? Highlight it. Press enter, and now I'm replacing the 4 with a 12. And I get 5808.08. So what's happening to the amount of money I'm making as I increase the number of times I'm compounding? I'm making a little bit more money. So now let's go back in and do 365. So arrow up twice, highlight it, press enter, erase the 12 and put 365 in its place. Press enter. I get 5809.14. 5809.14. Okay, 5809.14. Now I get down to the continuous one. What do I need to do on the continuous one? Use the second formula. So I'm going to have A equals 5,000. E to the 0.03 times 5.
Oh, is that a base? The E you drew up there is a base?
The E is the base, yeah.
Okay.
E is the base. So I need 5,000. I need E, and I want 0.03 times 5. So that gives me 5809.17. So 5809.17. So notice I make the maximum amount of money possible when I compound continuously. Okay, so when I'm doing problems like these, what's something I can do that will tell me, or what's something I can look at that will tell me I probably did it correctly? What do you know has happened here? They increased. What else? Continuous should be the highest. What else?
Get smaller exponentially. I guess you will.
The amount of money I'm making?
Yeah.
Okay, so the amount of money I'm making as I move up that margin gets a little bit smaller. So I'm making more, but I'm making a little bit less. Okay, notice the first one jumped quite a bit. How much money? I jumped about what, $9, and then I jumped about $3, and then about $1, and even smaller. So the amount of money I increase by reduces. Okay, but notice all these numbers are very, very close to each other. So when you do a problem like this, make sure your numbers are close to each other. If there's one that's smaller than something, or one that's really quite a bit bigger than all the rest of them, then you know you did something wrong. They should all be very similar numbers. Okay, so that's how you work a compound interest problem. When you're compounding at a specific number or compounding continuously. Okay? Yes.
Whenever we're like testing this, are we gonna get those equations or are we gonna have to memorize them?
I'll probably give them to you. Okay. Rachel, what is E?
Constant, irrational.
An irrational constant. Very good. All right, on page 166, we're going to do 16 to 26 even. And on 16, 18, and 20, we're only going to graph the g of x.